Hello once again, Geometry World. I've been reading your feedback and have noticed that some of you have said, Mr. Rising, sometimes your videos, you're wearing the same shirt. It looks like you're recording them on the same day. Well, in fact, that is what's happening. Sometimes I make multiple recordings in the same day. Thanks for paying attention. Hey, this is lesson 7.3. We're talking about similarity in triangles. And this lesson, without getting into trigonometry directly, is basically the whole foundation of right angle trigonometry, meaning that any two right triangles that are similar, then all their corresponding sides are proportional. What we're going to focus on in this lesson is proving triangles are similar with some shortcuts, and then once we know two triangles are similar, we can extrapolate what the unknown parts of the other triangles are. So there are three theorems that we're going to deal with here for triangle similarity. And they, of course, are angle-angle, similarity, side-side-side, similarity, and side-angle-side. And so typically what you would do is you would, when you have these similarities, you just put the similar symbol after it. So SSS, of course, would be side-side-side, thinking congruence, but it could also be side-side-side similarity and side-angle. Oh, that was weird. And side angle side similarity like that. So let's just get right into it. So here you go. You have two triangles. One has a 90-degree angle. The other is a 90-degree angle. One has a 47-degree angle. The other is a 43-degree angle. Are these two triangles similar? Well, according to angle-angle similarity, if two of their angles are similar, then all three have to be similar, and therefore the triangles are. Well, let's just double check to make sure these angles are worked out. So this third angle here would be 90 minus 43, and that is 47. And this one here would be 90 minus 47, and that is 43. So therefore we know that these two, so that one's 43, that one's 43, that these two triangles are indeed similar. Okay, let's try another one. Here you've got two triangles. Now I don't have any angle information, but I do have side information. So if I set up ratios of the side lengths, if I know that all three sides are proportional, then I know these two triangles are similar. Well, what's it look like? Here we go. Let's go from big to small. 3, 3, 2, 2. So 3 over 2 equals 4.5 over 3, 4.5 over 3. If that ratio is the same in all three cases, then I know that these triangles are similar. And in fact, they are. So I know that these are similar by side, side, side similarity. Right? All three sides have a ratio of 1 to 5, big to small. Cool. It's really, actually, pretty much that straightforward. Let's look at a third example. In this case, I have two sides, known sides. I don't know that those are right angles, so I can't assume that. So if these sides were proportional, that would be good. How am I going to do this? Well, let's just piece it together. First of all, let's see if the sides are proportional. So 12 goes with 16, so I've got 12 over 16, and that simplifies to 3/4. 15 goes with 20. Again, I'm going from small to big, small to big, small to big. 15 to 20 simplifies to 3/4. So now I know my sides are proportional. If I only knew my angles are congruent, well, they are. Angle TXU is congruent to VXW because vertical angles. Let's just label that real quick. We'll use purple in this case. So now I've got side, angle, side, similarity, right? And then I can just paste that in to say, all right, I've got side, angle, side, similarity. So again, angle, angle, side, 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 angle, side. Is there angle, side, angle? Well, again, as long as you have two angles, you know all three. So any of those variations will work. We talked about congruence a while back as well. There are similarity properties as well. Reflexive, meaning the same thing in two different shapes. So two triangles being similar. Symmetric, meaning you can swap places. And transitive property is kind of that substitution rule. So if one triangle ABC is similar to DEF, and DEF is similar to XYZ, then ABC has to be similar to XYZ. It's kind of that substitution idea. Well, good. So what? So what does that mean? Well, take a look at this one. Are these triangles similar? Oh, it's a great question. I love this question. Because if they are, can you figure out what the length of RT is? So here's R to T. How would I figure that out? Well, first of all, let's figure out if these triangles are similar. I already know that angles S and T are congruent, and that information is given. I also know that angle R is congruent to angle R because of the reflexive property. So what I'm seeing here is you have, let me get out my handy highlighter. There we go. This triangle is similar, or it might not be similar, but we'll see if it is, to this triangle, right? So that's why I'm comparing angles S and T and R to R, because they overlap. Well, in that case, these two triangles have to be similar by angle-angle similarity, right? You see that they have two angles together, that means everything else is similar as well. Well, now that since I know that the triangles are similar, their sides have to be proportional. So 8 goes with 12 as 10 goes to this entire length right there. So 8 goes with 12, 10 goes to the entire length. Now, what do I have to do in order to figure this stuff out? Of course, we're going to cross multiply. Let's get some green in there. How do we do cross multiplication? The 12 goes up with the 10. The RT goes up with the 8. That's how you end up with 8 RT equals 120. Divide both sides by 8, and you get RT is equal to 15. So that is one of the more complicated problems, but we're going to be working on all sorts of variations of that. The big idea out of this lesson is when you get into triangles, there are 3 shortcuts: angle, angle, side, 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 and side, angle, side. And again, side, angle, side means the angle has to be included between 2 known sides. And that'll really help you out when we get into the bigger problems down the road.